thing is, if you're still not done with chapter 1, the main thing is to get the work. Show me some thought process. That's what I really want to look at, right? I tried on the quiz to take more points away if you didn't show me your thought process. Okay, you with me? Mm-hmm. Chapter 2, how many of you guys have tried chapter 2 homework out? I know quite a few of you have. Right, and you agree with me, it's a little more concrete, right? The set stuff, some of it's new, right, with the not stuff and whatever, and I can do an example problem because it seems like a few of the people I've graded have the same issues. And then of course we get into Babylonian stuff, which hopefully some of you guys find fun in a way, I don't know, or interesting, different, right? How long has it been since you really saw something different in math? Has it been a while? You with me? All right, baby. Okay. So that's why I love to teach that stuff, because so few students know it, but it's not so incomprehensible. You can actually kind of catch on to it pretty well. And for you guys, you need to remember that as confused as you were a few times learning that, your students are going to be at least that confused learning our number system, right? Because it's new to them. How long did it take us to develop that number system? Centuries. And we want them to learn it like just walking around the house singing our 1, 2, 3s, right? And we're like, it took our species, it took our race centuries to figure that shit out. Right? Some of us didn't even figure out a real number for 0. Okay, sorry. All right, I love that stuff. So what I want to do today is, I think I want to do a couple examples from section 2.1. We're going to finish up section 2.2. And then we've sort of already done some stuff from section 2.3, which is kind of nice. By the way, of course, when is the test?
Next Tuesday.
Yes, next Tuesday, so you don't forget test and vote. And this Thursday, we're going to finish up whatever we don't finish up today, and then we're going to devote the rest of the time to review for the test. I'm going to bring like a practice test, and we're going to kind of look that over in class.
Can that practice test be used like a study guide?
That's the point, yes.
Is it okay if I bring my study guide to the ARC thing?
No. You can bring it, but you better not look at it. It better be somewhere else.
Okay.
They're not going to let you take it in there.
Oh, one more question.
Yes.
I noticed that I did forgot to do 21. So how did I do it? I know it's like some finding
Is
the
21
pattern.
one about cubes?
Yeah, it's about cubes. It's like finding the reasonable 6.
Oh, it's the one about the toothpicks.
I think
Is that
it's
really the
21.
one you forgot?
No, that was 20.
Okay.
The 21's different.
No, wait a minute. Are you in the right section?
I'm on one.
Are you in the
chapter
right
1.
section, A or B?
I'm on
Which section is this? Look at the paper.
That's
No,
B.
look at your paper. Which section is this?
It's B.
It's B?
It's A. Wait. A 1.2A. Yeah, it's 1.
It's A. Okay. So you need.
Wait. Oh, yeah.
All right. Make sure you've got the
Yeah,
right section and stuff here.
Because you put in 21, because it says 1.2.
Make sure you're looking in the right section. I don't think that's the right problem.
So for this one's mine, right?
Yes.
Is there like a certain amount of like blueberries that can go on top? Like, is it up to a certain number? Because I'm just having like a hard time distinguishing like the place.
Oh.
Does that make sense?
Yes.
Like, looking at it, like I would think it would be 14, but then the answer was actually 52 because it was
Yes.
2 separate place
Yes,
values.
yes. So with the Mayans, they were a little bit better about formalizing their stuff, because with Egyptians, they could kind of put their symbols anywhere.
Wherever, yeah.
Babylonians, we're going to talk about a little bit. They also sort of did that a bit. Mayans, if I have this, does anyone know what number that is in Mayan? Do you guys remember what the blueberries represented?
One.
Ones. And the pancakes are?
Five.
Fives. So what number is that?
14.
14.
14. What if I had this?
52.
So they're much more formal in how they develop their number system. This is different from this.
So if it's
Right? So
stacked,
the blueberries have to sit
flat.
flat.
Okay.
Yeah, yeah.
That helps.
So this actually represents, this is in a place, this is in, so what were the places? And again, I'm going to give you the places. This is the ones place,
That's the 20s.
20s. And the next one would be 18 times 20, but thankfully we don't have that. So let me take out all my extraneous shit here. So how many 20s do we have?
2.
Two.
So
2
40.
20s? 12 ones? That's how they got.
Okay.
Yeah.
That makes a lot.
That's a little detail I left out. It's my fault.
Oh,
Thank you.
It turns out on 1.2a, it only, on the homework, it said 13 through 18.
This is 2-1.
Yeah, that's 2, but the one, if this is, if I'm looking at 1.2a, that's what I just said. And you said 21, where's 21, but you said,
Oh, I must have mixed it up with 1-1. Okay.
Yeah.
You're right.
yeah, that's.
Okay. All right, guys. Anything else before we get into explaining something neat that I didn't even know the textbook put in there about Babylonian stuff? No. Okay. Yes.
15 is section 2.1a.
Oh, that's right. I wanted to do. Is that one like? Let's see. Yeah. Okay. Beautiful. Perfect. Oh my God. You like read my brain. You're freaking me out. Let's. So part measure. Do I have? No, we don't. Oh, there. My poor little markers. All right, now, if I have a universe, I have a set S and a set T, so that they're like this. Universe, right? Okay. And we are in universe 7, just like. True. What would this be?
Not everyone except for us.
Everything that is not
S.
in S. So sort of like you're gonna do the exact reverse of shading S in, correct? You just want to shade everything that isn't in S. So I would shade for this. I would shade. Yeah. Okay. Yes. Okay. You gotta be a little careful, man. Sometimes that slips over. I don't know if you intend to, because you don't want to include this piece either, right? Because that's obviously in S, and this says everything that ain't S. I gotta throw all the S stuff out. Now, what if I asked you, what is this? What do you got, Jeff? It's you?
Yeah,
Okay, all right. And how do you know that?
because you're not including what's S and what's in T.
You're not including,
What's the S and what's in T.
so it's not S or T.
So it's not S or T.
So you could, this was not that hard, maybe you realize that if you have everything that's not in S or everything's not in T, that's basically everything, right? All right, so maybe that's too easy of a problem. But those of you that couldn't quite see that, it would be easier if I have this represented here. If I could represent this, then I could more easily answer this question, right? I need a visual of what that is. Yes?
T. It was S minus.
Oh, yeah, okay. We'll do one like that. So this one real quick. Not T would be the same thing, of course, except U. I don't know why I have a Christmas theme going, but I just do. So not T, just don't shade T in. Make your own song or whatever. And now if I want to do this, so I say now I've got to take everything that's in this or in this. Now, is there anything that isn't in either one? Is there anything that is not in one or the other one? Because this is or, correct? Is there anything that is not in one or the other?
That's the universe. No, I'm sorry. That's union, and that's not in S and not in T.
So is this piece, is this piece in one or the other one? Yes, right?
Yes.
Because it's in this one. Is this piece, this moon here, in one or the other one?
Yes.
Yes, it's in this one. This stuff out here is definitely in one or the other because it's in both, yes? So are you certain? Is there anything that would not be shaded? Is there anything? Yes? I like somebody in the back is like, this piece. Yes, this piece. Is this shaded in either one of these?
No.
So why would it be a part of this? To be a part of this answer, you must be in this picture or that picture. Maybe?
I think
So that's why you had to be careful back there. Yes?
I think I'm starting to get that, what it means, because you had to say what's not in T and what's not in S, like completely. So if the only one that's not completely is the one in the middle, while the universe and the S and the T
Yeah.
are like all.
But this is a much easier question to answer if you have both of the pieces represented.
So
Right.
if it's unionized, would it mean everything?
It would mean everything that is in one or the other. That's why it's or, right?
So just
Is the intersection in one picture or the other one?
No.
No. So it can't be in the answer. Right? Is this in one or the other? Yes, that piece is in one or the other. That's why it's part of the answer, right? So what does the answer look like then? It's going to be everything except the intersection. So you're just not going to shade this piece in here. You're going to shade everything else. Whoa, 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 whoa. Whoa, 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 whoa. I really want that to make sense. Watch. If one set is 1, 2, 3, and the other set is 5, 6, 7, what is A or B? Is it the first 7 numbers? Is that the answer?
No.
Why not?
Wait, yeah. Wait.
Is it 1 through 7? That's the answer? The first 7 numbers? Why not?
Wait, yes.
No, it isn't. No, it isn't. What's missing from both? Neither one has a 4. Yes?
Yeah.
So you have to throw out the thing in the middle because neither one of them has it. So does this picture have the middle? No. Does that picture have the middle?
No.
No. So the answer is everything that is in one picture or the other one. So I got to throw that middle out. It's not in either one. It's like the bouncer saying, you got to be rich. Shit. Or you got to have nice clothes. Shit. And that's it. So I'm out. Right? I don't have either one. So I'm out. Okay. Maybe. No judgment. I can judge myself. I like it. Okay.
How do you, I have a problem remembering why union, not why, but which one is which, like union is or and intersection is and. I don't know how to remember.
How do you spell and?
A-N-D.
A-N-D. Let me just take that. There. And. And then when your mom's really exasperated, did anybody have a sibling? And your mom's like, you, somebody freaking clean this place up. You, or, right? That's or. Shabbat. That's how I remember. I don't know. That might be silly.
I also think for the intersection sign, how like if I'm arches, like I did union like white piece did, and then intersection I went like smaller,
Oh, neat.
like the middle part of it.
Yeah.
I don't know. That's just what I did.
So yeah, you can make up your own stuff if you don't. Yeah, totally. I mean, I made up that shit that I just told you. I totally made that up. That's an A. Take that out. So that's and. But you can make up your own way to remember why they mean what they mean. There's no like inherent biological reason that this is and. Does that make sense? There's no like cosmic, this is and according to the creator. No, it's bullshit. We just made this thing up. So we got to figure out as a human, we have to go, okay, my fellow humans did this shit before I was around, and I just have to figure out and remember what they called it. Remember what it meant. Yes, maybe? That's how everything is, by the way. That's why math is hard. We're all trying to catch up with centuries of work that other people did.
I'm still trying to catch up with the whole union rule, and how would you best practice these problems? Best by
Doing the homework, and if you feel that the homework is not enough practice, do more of the problems than I assigned. Do the ones that have the answers in the back. So do more of the ones from the part A sections, right? You guys all know all the answers in the back of the book?
What was that website that you were using? Do you know what I'm talking about?
Yes, and what sucks about that website is you would have to pay like a stupid amount of money to get
What?
access to it. So, yeah, I know, it's
Pay
stupid.
for that?
The one that I had the videos, wouldn't that be
No,
cool
not
if you
the
guys could just look at that yourself?
No, the clicking.
Like you were like.
No, that's on there too.
Oh, okay.
There's a stupid amount of resources on that website, but it costs a dumb amount of money. So, I mean, if you have a dumb amount of money, I could tell you maybe how to sign up for it, but I'm not gonna make it required. I'm gonna show you whatever from that is good, but it would be great if you could look at it yourself, right? I'm sorry. Yes.
There were some, I actually did that problem, but it said I had to explain. What is there to explain about when I just showed you the pictures?
So, if you have this problem and you give me this answer, that doesn't show me what thought went into it. This would be a very difficult one to figure out without drawing yourself these. I need to see some kind of thought process that leads to your answer. Because that is the most important thing for a teacher to see, is what your thought process is, right? I almost don't give a shit if the answer is right. Now, obviously I do. But compared to the thought process you went through, that's more important. That's where I can help. If there's just a number and it's right, I have no idea if that was a guess, if that came from nowhere, if you have the solution manual, I don't know, right?
Yeah, I understand,
Okay.
because I was like, do I have to explain it in words? 'Cause
So, yeah, you can explain it in words, but it's easier in this case to explain it visually. And this is how I would do this problem. I would give myself what that looks like, and then I could do that. Some of you guys, if you're able to go from here to here, I want you to teach me.
Gotcha. One more question.
Go ahead.
I was working on
That
the
was you, right?
Egyptian, on the Egyptian problems on 2.2, and on 9, can I still do the ones with the sticks?
Yes.
Or do I have to do the whole subtraction thing, like the Roman numerals?
Egyptians don't have the subtraction thing.
Oh, okay.
Yeah. You and then you, sorry. Or did you have your candle? I can't remember. Go ahead. It was over there.
Mhm.
2.1 B3. Okay. The little E sign. All right. So if I said, "Is this true?" Is that true? Now you're like, I don't know, because I don't know what this shit that is, Jeff. That's what I just asked, man. Who remembers what that symbol means?
An element of.
Is an element of.
So, no, it's not true.
Is 4 an element of the odd numbers?
No.
No, so that'd be false. What if I did this? Is that still false? Totally true. 4 is not an element of. That's totally true. You guys with me a little bit?
Yes.
All right. You're like, we're in the same room as you, Jeff. Is that cool? Yeah. Okay, so let's get back into
2.2?
second.
2.2?
Yes, 2.2. One thing I want to talk about right now is the Babylonian stuff. So it's kind of cool. I didn't even notice this book brought this up. In case you've been trying out the Babylonian problems, 2 things. I am very used to working with Babylonian numerals. Like this is how I'd write 14. You guys remember that? Is that cool?
Yeah.
Little thing here is 10, and then 1, 2, 3, 4, yeah. The book, of course, I really hate that they decided they had to do this, but it's fine. So they would actually do something like this, possibly. That's still 14. Right? Sort of like Egyptians a little bit, but they have a little more constraint. They can't just be anywhere they want to be, but they're all one little piece. So if I had like this, what are the places? Do you guys remember the places for Babylonian? Remember, it's related to our minutes and seconds.
6.
So it's based on 60. So this is the ones place, as they always are. The first place is always 1. But the next place is going to be
60.
60. So how many 60s do I have? 160 plus
14.
14 ones. So me stop for a minute.
Babylonian, right?
Huh?
Babylonian.
Babylonian, that's right. Let me put the whole name up. Babylonia.
I just call them babies.
Babies. All their work they did, they're like, I was telling you earlier, so they're gonna come back and say, what are we called in the modern era?
Babies.
Okay. Now, the book has a really cool thing. I told you that Babylonians did not have a symbol for 0. They did invent a placeholder towards the end of their civilization. The book actually talks about it, which is new to me. Most books don't even talk about it. So if I see this, gotta remember now. See how you got two that are pointing the other way? They didn't think of it like this. They thought of it as a placeholder. So there's 1, 2, 3 places there. Do you see that? And we can think of that number as 0. We can think of this as meaning 0. So what are my places? Ones?
60.
60s?
Oh, 60.
360.
3,600.
3,600.
Cool, that guy. Let me ask you real quick, how many seconds in a minute?
60.
How many minutes in an hour?
60.
So how many seconds in an hour? 3,600. See, so it's just the next level up, right? So do you see the difference? I really want you. Do you see how I try to make this the same and this the same rest? But it had this in the middle. That sort of is like there's 0. So that tells me there's 1, 2, 3 places. So if I'm doing this work, if I'm you, this is what I'm doing for myself. I'm putting a little line under each place, then I'm building the places. 1 times 60, 60 times 60 is 3,600. Are you guys at all with me? Yes?
I have a question, but it's about Roman numerals. So.
Okay, hold on.
Okay.
So whereas this would just be 1 3,600 plus no 60s plus 14. So it'd be 3614. Okay. Yes?
Is that the only time you're gonna see like the triangles pointing upwards, like that always indicates number?
Yeah, those 2 triangles like that pointing upwards means placeholder. Yes. Now, there is more. There is a shit ton more to every number system we're talking about. I pointed out a little bit, like the Egyptians had a way to do fractions, right? Believe it or not. Are you with me? Romans had a way to multiply by 1,000, all this kind of stuff. There's a lot more to every single one of these. So we're just kind of scratching the surface of each one. I want to say that. But in terms of what we got to worry about, yeah. Okay.
So for the Roman numerals, one of my answers was have to change it. I ended up with over 100,000. I'm not trying to get that in Roman numerals because you can't do it.
You had to do what? Which one?
It's 2.212C. On B.
One B, okay. 12.
I think they gave you in Mayans, maybe. They gave you in one of the sections. And then you
So
have
it's
to
the
change it.
Egyptian, I can almost see what that is. I'm gonna have to break down and bring my freaking glasses with me. The first thing is a pointing finger, is that what that is?
No, fish.
It's so tiny. That's a fish?
I
Sure.
think if it's
You and your young eyeballs. Alright. So what are you worried?
I'm not sure how to get the 100,000 in Roman numerals.
Oh,
Unless you just multiply it or something.
let me
We
see.
didn't learn that.
I'm pretty sure. Let's see if they told you this. I do believe I told you, but I don't think the book tells you, which is really evil. Yeah, I guess not. So here's something cool. Here's something really cool. You don't have to remember this, but anyone remember what that means?
40, 50.
50. If I put a line above it, that means 50,000.
Oh.
So that's why, if you ever see somebody write a Roman numeral 1 like that, they're actually wrong. Because that sort of means 1,000 in a weird way. We actually use M for 1,000. I don't think the book even tells you that. It's just a little bit evil. That's strange.
Sounds about right.
Oh, I'm sorry. Oh, there it is. Yes, they do tell you.
Oh.
On page 62, they really bury the lead on this one. So there, they tell you right there, V means 5. So V would be 5,000
Okay.
on page 62. They really, really bury it down. So thank you for pointing that out. So if I wanted to write 100,000, I would just write the
C with
symbol
the
for
line.
100 with the line over it. I love it. Kick ass. Okay, maybe. So, I got the thing about the Babylonians placeholder. So let's do this. Let me, all right. I wanna, can you guys promise me, well, all right, there's a lot of problems on the sheet. We're not gonna do all of them, so don't even look at the problems yet. At the bottom, I've just got collected Egyptian symbols, Roman numerals, Mayan numerals. I've got Chinese down there too. We're gonna talk a little bit about ancient Chinese numerals. But for right now, I just want you to have a quick reference for these things. Sure. So at the very bottom, you're gonna see how I try to collect information. So, one thing we haven't really done much of yet is converting from our system to a different system. That's always more difficult. So just to show you what I mean, what would this be in our system? So you can all look, see the Roman stuff at the bottom of your page? You need to remember. What do you look for again in Roman?
If there's a smaller in front of the bigger.
Smaller in front of a bigger. So where does that happen? Let's underline those.
C and M.
CM,
XL.
XL.
IV.
IV is kind of like we know that's 4. We almost don't have to worry about it. So now I can figure out what is M? 1,000. CM means 1,000 minus
100.
100. XL means
40.
50 minus 10
whoa, 50 minus 10.
plus 4.
You gotta share this stuff next time. And then the last thing, of course, is 4. All right, now I know I kind of. You need some water? All right, go get some water.
Sorry.
That's all right. I used to get the hiccups, and my teacher would say, "Show me you got the hiccups," and they were gone. I'm like, "You scare me, person." So anyway, does everybody see when so when you convert from a different system to ours, I'm not saying it's always going to be easy, but it will definitely always be easier, right?
Mm-hmm.
So this I just got to put it back together. I get 1944, yes?
Mm-hmm.
So if you see that at the end of some old black and white movie, that means it was made in 1944. Yay. So, what if I want to go, what if I have the number, what do you got, Jeff? Okay, let's do 828. And I want to take that to Rome. What do you think in your head?
Could you do three C's in a row?
Yes, you can. What is the rule? You can only have up to 3 in a row. If you think you need more than 3, you don't. So you got it. Why are you saying that?
Because you have 500 and then
Good. So 800 is 500. And again, what are you kind of gravitating towards? You're going to see this across all of the different number systems. What is the biggest thing that I need to use to start with? Because then you can kind of whittle down what you have left, right? So 500 is the biggest thing I could use. So I got 500 plus, of course, 300. All right, now that I can write, no worries. 20's pretty simple, right? Plus 20 And then I need an 8, and that's pretty simple also, right? Maybe? I don't know. I don't want to assume anything. So what's 500?
D.
D. And then each 100 is C. 20 is going to be 2 X's. And then 8, of course, we all know 8. Become an 8.
It's a long number.
I know. And again, I looked this up a long time ago. I need to see if I can find it. What did they actually say to each other? They did not say, this right? I really can't even remember. It's been so long since I looked that up. How did they communicate with each other?
Did
This.
they say all the letters?
Say again?
Did they say out all the letters?
No. Each letter is actually part of a word, right? So there are words behind these letters. If I were them, I would just round to the next whole number, make it easy. Okay, what if it was 929? Take a minute and see if you can figure that out. You guys also use red. Sometimes students aren't as red sensitive as they could be. Okay. You guys notice I don't use red ink to grade your stuff. That was a conscious choice. It wasn't just because the nearest pen wasn't red. Red is such a, it's blood.
Is IX 10? I mean 9.
So break it down. It's got a smaller in front of a bigger, right? So that means
Yes.
you're going to subtract the 2. So it's
9.
10 minus 1, yeah. So what's wrong? Why can't I do it pretty much the same way I did this one? Because how many would I need here? I would need 400. Shit, I can't have 4 in a row. So what's another way to make 900? Yeah, good. It's 100 less than 1,000. I love it.
20 left, or 29 left, and you get XX.
Yeah, 29, so it'll be XX for 20, just like we did up here.
And then IB. Or
And 9, of
IX.
course, IX, right? So we're all so used to IX because we see that a hell of a lot more. Sometimes you see them on clocks, and you see them when you make the little outline shit, right? Roman numerals for my outline. But we're not used to this, for damn sure. Right? You never see that, unless we're talking about centimeters. But it's the same idea. It's exactly the same idea. So it will be more difficult to go from our system to another system. So here's one example. So let's do some more. Let's do Babylonians, because we just did them, and they got a relatively simple base. So if I had to take, what is it, Jeff? You got something. Put it down here. 5,917. Hindu Arabic. I want to change that to Babylonian. What are the places in Babylonian? What's the first place? 1. 60.
600.
And we did this once. Somebody told me what this next place was.
72.
No.
No, that was the.
That was mine.
Mayans.
I like it. This, I think, is 216. Is that right? I'm pretty sure it's 216,000. Is that right? Do you have that thing in the right place? I can't remember. Anybody help me?
Isn't it 18 times 20 squared, right?
It's 216.
It's 60 times 60 times 60.
Oh, that's right. Okay.
Is this?
Yeah.
Okay. All right, and that's obviously too big, yes? So again, what is beautiful about place value systems is to convert from our numbers to theirs. I go as high up as I need to, right? The next place would be too much. Do you guys see that? It's bigger than the freaking number is. So I obviously don't need that place. So what I try to tell my students when I teach them this stuff, always have a place that you cross out. So you make sure you go far enough. That's going to become a bigger problem when we start doing base 5, base 7, base 12, base 16. Right? If you don't go far enough, you're going to have some weird shit happen down here. You need to make sure you go up high enough. To do that, you go too far. One too far, shit. So obviously, how many of these? One. What do I got left?
38. Oh, sorry. 2,317.
2,117. All right, let me stop for a minute.
I did.
Let me stop for a minute. That's why I go up as high as I can, and I start at the highest point. So I see how much of the number can I take care of with this highest place. What have I got left over? Now I've got 2117 left over. Go to the next highest place. How many 60s? Yes, sorry. Or do you have the answer?
It's 237.
Oh, thank God.
It's what now?
It's
237.
You got the answer.
Oh, of course I did. Just because. To show off my incredible ability to make mistakes. Now, so it's 2317 I got left over. How many 60s can I use to take care of some of that 2317?
38.
How many, sir?
38.
38? And 38 60s is what?
200.
22,
2,280.
80?
Well, no, wait.
Yes.
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 Okay, I'm with you. And when you subtract that, you get 37. Yes? Double
Yeah.
check me on that. I
Yes,
don't trust
you're
myself.
correct.
So then 37 has to go here. Now, I really want you to understand, don't be mean to yourself. The Babylonian symbols are pretty simple, but why the shit add extra steps all at once in your head? I know this is not the answer because it's not written in Babylonian yet. So in Babylonian, I'm going to let you do this like I do. I know the book uses a full caret,
I do that.
right? Yep.
For the tests and stuff, will you allow us to do the minus symbol?
Definitely.
Okay.
So I'm going to write this in two different ways. To write 38 directly, it would be 30.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, right? Is that cool? That's 38. I'm going to do it a different way in a minute. And then 37 would be 30, 1, 2, 3, 4, 5, 6, 7. So another way to do this, so this is one beautiful little answer. Kick-ass little answer. Any questions on how we got there? This is how every place value system conversion works. So what's the other way? The other way to write this is just because Babylonians had a symbol for minus. So I could do 40 minus 2, isn't that 38? 40 minus 2. And then of course 40 minus 3. So those are the same number. Same number. So maybe just depending on how good my hand was feeling after all the chiseling I've been doing. Let me do an example of Mayan. I'm going to do this example and then I'm going to give you a few from that sheet to try out on your own. So let's do, so remind me about mine real quick. The symbols, of course, are blueberry and pancake.
And they also have a 0. It looks like a bowl
Good.
to me, a burrito bowl. I don't really know.
Looks to me like a bun or a toe, right? I prefer a bun.
In the book, I just want to point out, it looks a lot different. It has all these lines and dots, and I'm just like, okay.
Oh,
That's why
I
you're
see.
thinking.
All right.
Yeah,
Well, this is the
That's what
way,
they-
Yeah,
mean.
yeah.
I'll try to do it the way they've got it. That's the way I was taught a million years ago. So they got it like this.
Looks like a UFO.
A UFO, I like, or it looks like to me like a mushroom top.
Oh yeah.
If we're going with the food thing.
Okay,
Yummy.
so this is 0. So I'll try to draw it the same way the book has it. Their Egyptian symbols line up pretty well with the way I was taught, but some of their other symbols are different. All right, and their place value system is weird. These are the weird guys. These are the weird guys, yeah. So they have 1, and then it looked like it was going to be a base 20 system, and then they build it vertically, right? So they have a 1's place, a 20's place. The next place is not 400.
It's 7,200.
That's the next place after.
Oh, 360.
Yes, so the next place is 18 times 20, which is 360. And then 20 takes over again. 18 times 20 squared, 7,200, and so forth. So it's almost a base 20. Can you guys see that? Base 20 would mean 1, 20, 20 squared, 20 cubed. And of course, we all know why they did what they did, because it's based on, why did they try to make 360 show up?
The year.
The year. That's it. This does lead to some, well, I don't know if it's going to come up. We'll find out. It leads to some weirdness as to 2 different ways to write certain numbers. But we'll see if it comes up. So what about, so first question, let's do one straightforward. What number is this? I just love that's a number. How many places are there?
2.
Good. There's flat blueberry, so this is one place, and this is one place. There's 2 places. So I'm only going up to the 20th place, right?
Mm-hmm.
What number is this? I mean, what does this symbol represent? 5. So I got 5 20s,
700, 5, 6, 7,
8
8
ones.
708.
Yeah, 108. Can we stop for a minute? See what you think about going the other way. So what if I had to do, so in Hindu Arabic, let's do the number 407, and I want that changed to Mayam, there it is. And again, as you're doing this, understand this is how your students will feel as they're working with base 10. They're going to build each number up the way we are, because they're not used to any of it. Well, depending on how low of a grade you teach. How far up do I have to go? What's the highest place I need?
360.
360, I like it. So we're converting 407 from our system, we're converting it to Mayans. So here's what I would do for myself. So I'm going to put down the places, right? The first thing I'm going to do, I'm not going to worry about the Mayan symbols. I'm not going to try to do too much at once unless you feel like you can. How many 360s, of course? 1.
2 times
Yeah, so then I got how much left?
47.
47. So I need 2 of these,
Which gives us 7
7
left over.
7 left over.
7 ones.
And then the last thing I do is change it to symbols. And again, you don't have to do it in that many steps, but
I do.
you give yourself too many things to think about at once, right? What's up?
Oh, that's how I do it.
Oh, good. Yeah, I highly recommend it. And then you can just change it. Now, obviously, you don't leave it like this. But it'd be 1, 2, 7. I just love that. But that's a number. Isn't that cool? Of course, you guys at home can't see it. Sorry.
Yeah.
Yes.
When you did under the Hindu Arabic. Under the Hindu Arabic, the 407,
Yes.
what did you do?
The minus.
Yeah.
Because if I use one of these, I need to see how much is left. So it's kind of like, let me see if this makes sense. I'm trying to cover that number. So if I use one of those first top places, how much do I have left to cover still? So I've covered 360 of it, so that means I have 47 left. Oh, if I use 2 of those, minus 40, now I've only got 7 to cover with the last place, yeah. And you always have to use the most you can of each place, right? Isn't this foreign? Of course, it's by definition foreign. It's freaking Mayan numbers. But I mean, the whole concept is not hard. It's just different. Yes? Okay, I like it.
JVs and Mayans are easiest for me because I don't have to remember a bunch of different symbols.
Yeah,
That's
but
how
they have Babylonian and Mayan have very few symbols. I love
Romans
it.
and
I love the,
Romans are insane because the things aren't even in alphabetical orders.
I like the Egyptians. They're more easy.
Of course, they didn't have our alphabet. So,
I like the Egyptians.
Egyptians are really kick-ass. But again, if I give you the number 9,999,000, which I'm not going to, you'd just be sitting there drawing forever. Astonished person. Astonished person. Astonished. All right. Okay, so what I want you guys to do.
Oh, Mr. Walner,
Yeah.
what time do you leave after school? I mean, like after class is over. What time?
So I got to be over for office hours at 2:30. Did everybody get the updated office hours?
Yes.
yes.
So you got to check your Canvas. So I'm in the classroom next to my actual classroom at 2:30 because I have a 3:30 class. So I got that little bit of time between our class ends and those office hours start, and then when that class is done, I'm pretty much done. So,
Okay, because I just need to talk to you about something after class is over.
yeah, sure.
Thanks.
Yeah.
So on a test, are we gonna have to convert like that and then draw it out?
Sorry.
On this test, are you gonna want us to do that and then draw it out?
Yes, you have. Your answer has to end up being Mayan or Babylonian completely. Yes. So there's nothing wrong with this step. It's just not the answer yet. This is just us doing the work in our system, and then we go, okay, the answer in their system is this. That's the answer. All right, so on this sheet, right, everybody got one of those?
Yeah.
Do number, let's see, let's do this. Do number 39. Let's see, 39. Did I give any of these? Yes, I did. Do 39 and 48. Let's just start with this two. Here, I'll put the Mayan places up here. Oh, in one more place, good job. I think you have to go that far.
Was not the one you want us to do 39 and
39 and 48. Jeff, pick this up. Oh, yeah.
do Babylonian of these.
Alright, so what are the places in Babylonian? Do you remember what their number system is based on? Ours is based on 10. But theirs is where we got seconds and minutes from. What are theirs?
1, 20, 30.
So how many seconds in a minute?
60.
60. Their places are 60. So it's one's place. So it goes this way, of course, right? One's place, 60's place, 60 times 60, 3,600. So like our system is, right, look, our system is ones, tens, 10 times 10 hundreds, 10 times 100 thousands, right? Theirs is just built on the number 60 instead. Good, so I would put this, so there's our ones, 60s, 3,600. The next one would be 216,000, because you multiply this by another 60, that's bigger than our number, right?
Yeah.
So now tell me, the biggest place, how many of those go into that? How many biggest place? It's 3,600.
Mhm.
How many of those go into that? You can use your calculator.
Going to this.
Yeah, so you take 7280 divided by 3600. You only care about the whole number. So 7280 divided by 3600. 2. Do you see that? 2 an extra shift. So, and it makes sense because in your calculator, can you do 3600 times 2? What are 2 3600s? What does that make?
Times 2. That'll be 7,200.
Do you see that makes sense then? Because the number is 7,200 something.
Mhm.
So if I put 2 there, put a 2 there, so I need 2 of those. Now, what do you have left over? We've taken care of 7,200 of it, right? So how much do we have left over that we haven't done yet?
80.
80. Now look at this. Can you just tell me how many 60s go into 80? You don't have to do that, right?
20. Because you're adding.
How many 60s go into 80? So 2 60s
One.
is too much already. Yeah, just 1. So put a 1 on top. All right, so now you had 80 minus 60. How much do you have left over?
That'll be 20.
20. So you have to put 21s.
21?
Yep. No, 20 ones, right? You need 20. That's how much. There you go. So 2 of these, 1 of these, 20 of these makes this number. Right? Okay. So we've done the work. Now you just got to translate that into symbols.
Like, are these the Babylonian symbols?
No, that's mine.
Okay.
Babylonian I didn't even put down there because they're just, so the Babylonians are these 2. This is 1, this is gather. This is 10.
This is 1, this is 10. Then how would I make 3600 then?
What does that 7 mean?
Huh?
What does
Oh, yeah.
that 7 mean?
The 7B?
No, what does that 7 mean?
Oh. Hundreds? No, thousands.
Thousands. How do you know it means thousands?
Because it's in the thousands place.
Because it's in the right place. I love it. Hold on just a minute. Anyone got the baby one done? Want to put it up here? Anybody feel like you want to put it up here on the board? No?
The
Come
baby
on.
one, I can do it.
Yeah, come on, do the baby one. Anybody want to do the Mayan one?
I missed one.
Blueberries and pancakes? You don't even have to pour any syrup on it.
I did it wrong.
I have the baby.
Go for it. Try to show your work too.
Oh, you want it?
Yeah. It's too late to go away. You're right up here. Nobody wants to do the Mayan.
I accidentally solved it wrong.
Okay. All right. I'm sorry. I don't mean to push you.
I just start off like that because that's how.
Yeah.
And I realized that when I did it, I got 3600 can only go into 7 to 80 twice.
Twice.
when you subtract that, I don't remember what that was, I didn't write it down. You would get 80,
80 left.
and then you would have one of these, or, yeah,
That's right,
yes, and then
160.
20 left over.
Good, all right. Is that pretty much, we're not done yet, of course, right? But does that match with what you guys did? Yes, everybody?
Yes.
All right,
I need it just this one.
there you go.
You want me to do the?
No, it's okay. See if anybody else, nobody else wants to?
In a minute.
Yeah, like it's voluntary too, I ain't getting up there. All right, fine. Did anyone get the Mayan one done yet? I know.
I did it, but
You did? But you don't wanna come up
here?
here?
Wrong.
I don't blame you. I could turn the camera off if you're.
So by adding two hash two sticks, that'd be thousands?
Yeah, so the two of these, so here's the, so two of those was 7,200.
Yeah, I was confused.
So we had 80 left.
I had 72.
160, now I've got 20 left, so they all have to go here. This symbol is 1, so I need two of these, so 1, 2 of those. I need one of those. 20 of these means 10, 10, right? 10, 10, that's 20. Okay, very well done. All right, you guys help me do the Mayan stuff. How far up do we have to go?
Up to 7,200.
7,200, I like it. Now you just have to, you can do this in your calculator, right? You just have to ignore the, I want to show you something kind of cool. Let me see if we can do it with this. Somebody redo this. So you got to go up to 7,200. So in your calculator, you should have done 17,913 divided by 7,200, yes? Okay, so what'd you guys get?
2.
2-point stuff.
Yeah.
This,
They're back.
sorry. If you need more water, you can go get more. Okay,
It was a long walk to get water.
it's 2-point stuff, right? Okay, so that's why I'm gonna put like a 2 here. But here's the cool thing. Does anyone have the 2-point stuff on your screen right now? Let me see if I can put it up here. Sorry? Okay. Do -2. Enter. Now do times 7,200. What do you get? Yeah, what is that number? So what's 2 7,200s? Isn't that 14,400?
Yes.
Yes? And what do you get when you subtract that?
3,913.
33513, yes?
I got 3,900.
Now listen, you don't have to do it this way. Do you understand what just happened?
Yeah.
Or at least you see where, okay. If you do 17,913 divided by 7,200, if you do it in your calculator right now, if you want to try this, do it. I want to show you, this is cool. And you get the 2-point shit, right? Subtract the whole part, so subtract 2 in this case. And then you get the 0.45, whatever, right? Now multiply that by 7,200. Multiply it by what we just divided by. What do you get? Holy shit. I want you, we know what that 2-point shit is. What is this shit? It's the remainder. So it's like the part out of 7,200. So if I multiply by 7,200, it actually tells me how far off the number was, which is what the remainder is. Do you have to do it that way? No, but it's just kind of nice. I want you to realize the rest of the number means something, right? But you don't have to do it that way. Okay. What's your one? So obviously, maybe not obviously, but wouldn't 10 of these be too much? Do I really need the calculator for this? Wouldn't 10 be too much?
Yeah,
So don't I just need 9 then?
9.
Yeah.
Which is 3240.
And 9 times 360?
3240.
3240? And when you subtract that, let's see what Jeff does. Did Jeff get it right?
Yes.
Go, Jeff. All right. And then, you guys, everybody with me?
Yeah.
It's the same thing over and over because that's how you build a number. That divided by 20, 13. Of course, that's 260. Well, I got lucky 13s. Look at that. That kicks ass. And now, of course, that's the middle work.
I got 13.
The middle work. Now, how do I write this? 2 dots or blueberries?
1 line and 4 dots.
1 pancake and 4 dots? 4 blueberries?
in a row.
Good, flat, I like it, good point.
Yeah.
13 is
Those
2 pancakes, 3 blueberries, and then of course 2 pancakes, 3 blueberries. I like it. Did the Mayans call them pancakes and blueberries? No.
Should have.
As far as I know, to be honest, they might have. Sure. All right, now. So you understand now, this isn't hard. It's just different than what we're used to. Yes? Okay. Oh, let's try real quick, just to make sure you guys are cool with this. Do number 6 and number 15. 6 and 15.
About 2
10,000 the finger? 10th finger, right? Just doesn't look like a finger on this paper.
Oh yeah, this is what I was telling you. That's the one symbol that I had trouble with when I was looking at the book. That is the one Egyptian symbol that is different.
It's the finger.
Yeah, this one's like somebody cut the fingers a different way. I don't know. But you're nice. All right, 15. Good old 1964. Jeff, I want ramen noodles. Stop it, I can't. There. That was funny.
I did number 8 for the Egyptian numerals.
Why did you do number 8? Just for fun?
Yeah, just for fun.
Oh, okay.
I'm just wondering if it's right because
Let me see.
of the zeros. I don't think there are any Egyptian numerals.
Zeros don't matter. See, that's why do Egyptians not need a symbol for zero?
6,000. Do you do like the 6 and the line over?
Why do we need a symbol for zero and they
Oh,
don't?
we're on Roman numerals. Say 15.
Ours is
Number 15.
places. So if a place is
Oh,
empty, we
yeah,
have to have
yeah,
something
yeah.
there. Egyptians don't have place value. They can put them wherever the hell they want to. It's just all
Because you
additive.
can't do 360.
What'd you put? Astonished, and then
M's in a row.
the flowers, because you got 3, right?
Mhm.
And then
Number 16.
44
Number
heels.
16.
Yeah.
We're doing 16.
Well, except for
Oh, I thought we were doing.
how many?
We're doing 15.
Oh, the twos.
I was like,
that.
Yeah,
Wait.
but otherwise it's perfect.
Thank you.
1964.
I wrote down 15, but
You
I
had
wrote
me
down the
scared. I
number.
was like, wait.
This is gonna be pretty simple, right?
I wrote down the wrong number for Romans.
Oh, okay. That makes it hard.
I wrote down 6,000. I was like, how do you guys do 6,000?
How did they do their finger?
Before we go.
Yeah, that was so weird to me. I've never seen a finger. And the fish is different. But, you know.
I have a
guess-
quick question. So on the test, like if we're going from Egyptian numeral to Hindu Arabic, and are you gonna want us to like show our work by like putting like 1 times 1,000 plus like 3 times 100? Do you know-
Oh,
do you know what I
no,
mean?
you don't have to
No?
do all
Okay,
that,
cool.
no. Unless I say so.
Seems really
That's like
redundant.
expanded form, but for Egyptian's supposed to be easy,
Okay.
yeah.
Thank you.
No.
Yeah.
I'm gonna give
And that was
you
Egypt?
all of this.
Mhm.
Except not this one, like, it's just
Finger caught me off guard.
I know that last Mayan one.
I'm also gonna give you, so on the test, I'm gonna give you all those symbols, and as I promised, I'm gonna give you the Mayan place. You gotta remember the Babylonian symbols in place, because that's easy, should be. What else do you have to remember? I think that's it. Yeah.
I do have a question. I know we didn't do this problem, but I accidentally wrote it down and I was very confused. How did you do 6,491 when you can't do 6 M's in a row? Would you?
So remember the line above?
But that's 100,000, right?
No, listen.
Oh.
You could do it
If
for
you had
B.
5 and you put a line above, that's 5,000.
Okay.
Yeah. Let's see. Who's got the Egyptian? Just tell me what is it? Little finger.
Spiral
Little
arms.
finger.
Let's see. So the way the book does it, it's like, oh geez, Jeff, that looks like a broken heart.
The little finger and then the
It's
two
like
little
that.
curlies.
Just don't say anything about my finger. I'm used to it being just like a little banana or something.
Okay,
But
the little banana.
the little finger and
The two curlies, the two
Yeah.
swirlies.
two scrolls, right?
Yeah, the two swirlies.
Yeah.
I call them swirlies.
Swirlies. I like it.
Me too.
Two swirlies. That's pretty easy. In fact, for that number, which system wins in terms of ease of writing?
Egyptian.
Egyptian, sort of, as long as you know.
It's less numbers than
Know how to make a figure.
Hebrew or Hindu.
Yeah. But I mean, Egyptians quickly lose. Very quickly lose. How about this Roman number? Let's break it down first. I don't know how you guys kind of think about this, but I need 1,000. How do I make 900?
I just
1,000 minus 100.
So the thing to think about when you're thinking about this, to make 900, I would need 504. Oh shit, I can't have 4. So I got to think the other way. Go bigger, subtract. There's one rule I forgot to say something about. I can't remember if I put it on that paper that I gave you the other day, but you can never subtract. So let's see, we got I, V, X, L, C. You can't subtract. So I see this, right? And I see this, but you'll never see this.
you can't stack if they're 3 apart or something like that.
Yeah, it's got to be at most 2 levels apart to put one in front of the other one. Yeah.
Can you write the line over more than one number or one Roman numeral or no?
Yes. Yes, I'm pretty sure you can. To be honest. Yeah, I think it
Like
makes sense to
5,000?
do that in a few cases. Why are you racing all this with me? Just because. Keep going here. 60 is not that difficult, right?
You want to do like 6,000.
It would be 50 plus
You do
10,
50i.
and 4 we all know.
You can make it out 6,000.
So I need 1,000. What's that? And then 1,000 minus 100, so 1,000
C,
minus 100, 50,
L, X,
10,
I,
I, B. I like it.
booyah.
your camera is not picking up on anything you're writing.
Of course it's not. They got these neat Zoom-enabled rooms on campus that I have not been in yet. Supposedly the camera follows you
Oh.
as you walk around. Okay. So, last thing I want to talk about today, unless there's anything else on here that looks weird. Well, the Chinese ones, there is a homework problem with the Chinese symbols. Chinese symbols are really cool because, number one, they're really neat to draw.
Can I take a picture?
But
Thanks.
I'm taking a lot of pictures too.
On the test, will you allow us to do it? No, they're Mayans. Would you allow us to do either for the 0 if we have to do the 0? The way you read it, like is it?
Yeah, that's the way I was taught. This right here.
Okay, yeah.
Yeah.
Got it.
Which is weird to me. So I was taught that way. This is in another book. This is my Math 120 book. This is the other class I teach this in. So that's why I'd never seen the way that this book does.
So you allow either, right?
Yeah, I'll allow either way, obviously. Yeah. Okay, what were you gonna do? Oh, Chinese. Chinese system is really kind of cool. They don't have a place value, but they sort of have in the middle of these and ours. So for example, the symbol for 10 is basically a T. Right, so you guys can see that down there, yes? 10, 100, 1,000, those are multipliers. So they do have kind of like a base 10 system, but it's not really a place value. So if I wanted to write the number, let's see, let's try something easy first up. 30, it would be 3 times T. So the way theirs works is maybe they'll have a 2 in front of 1,000, like they'll have a thousands place, a hundreds place, a tens place, and a ones place. So you have these 2 symbols together that are multiplied to make the place. So our system, this is 4,000 because it's in the 4,000s place. In their system, let me try and make it match. There you go. This is 3,000 because it's in the 3,000s place. In their system, this would be 3,000 if it was a 3 with 1,000 afterwards. How would they write 3,000? It would be 3, and what was your 1,000? Oh yeah. Yes.
Is this a multiplicative or a positional numeral system? 'Cause
This
that was
is
the question.
multiplicative/additive. It's kind of like, do you see how it's like one evolutionary spot away from ours in a sense? Right? So they don't really have the place meaning 10, 100,000, but they have a symbol meaning 1,000 and so forth. It's just one little evolutionary step away. And sure enough, it was evolutionary, this process of the numbers becoming what we use today. Is our system the best? In some respects, and in some other respects, it sucks. Yes. Oh, do you have a, I'm sorry, I thought your hand was up. All right. So that's theirs. There's a homework problem on the Chinese numeration system. But since the book doesn't really address it directly except for the homework problem, I'm not going to really put that on the test. You guys with me?
That one? I have a question about that one. For if there's a 0 in between 6 and, or like a number.
Which
so
one
like,
is it?
It's a 16, it's 16A. It's 603. I wasn't sure if I should put a 0.
What? Wait. Oh, 603 is the number?
Yeah. I
Oh.
wasn't sure if, because they didn't give us a 0 on
No,
the book,
yeah,
they
yeah.
gave us a 0
They actually
here.
do have a symbol for 0, but they
It's on
didn't
the-
tell us, did they? But all they have to do for 60 is basically 6 times 10 and then put a 3. It's understood that something by itself is in the 1 place. So you need a 6. Can I remember what a 6 is? That's a 7, right? I used to be able to remember all these. 6 is the little long-legged dude. 6T 3.
I
That-
did not that. I did the 6 and then the 100.
Oh wait, it's a 603, I'm
Yes.
sorry. In my head I thought it was 63. 603 would actually be exactly the same.
Just with
You would
the
just
100
have
sign.
the 100. Oh, the 100 is one of my favorite.
It looks like a wheelchair to me.
A wheelchair?
I
I always think about a
No,
birdhouse
that-
or a helicopter. Right?
think it just looks different.
Yeah, a little bit. This is the way I know. 603.
Yeah, that's what I have.
That's the nice thing with them. They don't need zeros necessarily because if it's by itself, it's a single digit, and this is obviously 600. So this is 603. I don't need a symbol for 0. They did have a symbol for 0, and it's so intricate. I understand why the book didn't show you. It basically looks like a face with its tongue sticking out. So if you ever want to look up ancient Chinese numeral for 0, is that on there?
Yeah, it's on here.
Yeah, there it is. I forgot I had it on mine. I don't know, shit. This is really sad. Just wait till you get old, kids. Can't read anything. Yeah, do you see it? I don't know if you guys see that. It might just be my weird brain that sees that. Okay. So, last thing. We've already kind of done this. And I could bring those out. We really haven't worked with those too much. Maybe we'll work with them first thing next time, but I want to talk about the math behind this. And then maybe first thing next time we can bring those manipulatives back out, because those are kind of neat. I don't know if you guys agree with me. Do you guys remember doing those?
Mm-hmm.
Little blocks in the cubes. But we did base 5. That's the ones that I had when I brought them out, base 5. I don't have that many, but I think I have base 6, base 10, and like a few base 3s. Not enough for everybody. Kind of sucks. Base 5 would mean, what would the highest single digit be? 4. So basically, no pun intended, in base whatever, the base will be represented by this symbol. So what does that symbol mean in our system? Because we have a base 10 system. So 1, 0 will mean the number that's the base. How does that work? Well, what are the places in base 5?
1, 5, 25, 100.
What's the street that goes north to come to Grossbahn? What's the name, the number? The 125.
Oh, it's a freeway, not a street.
Freeway, sorry. It's a street. Good point, though. Right when I said it, I'm like, they're going to think I'm talking about something else. All right, anyway. That has nothing to do with why this is 125. And then we'll just keep going 5 to the 4th, 625, and just keep going forever, just like our base 10 does, right? When do they stop? They never stop. So again, if I give you something that is in a different base and ask you to convert it to ours, that should be easy as shit. It's got to be. I'm not saying that to make anybody feel bad if you have trouble with it, but it's supposed to be easy. So for example, if I gave you the number 143 in base 5, what place are all those things in? Right? This should actually be a little bit easier than Babylonian and Mayan because we have our own symbols, just a different base. With the Mayans and Babylonians, different symbols, different bases, everything freaking different. You guys all right with it? So what number is this? I got one what? 125 plus 4 5s plus 3 ones. So what number is that in base 10? 48. Kick ass. So if we were born with a single arm jutting out of our stomach like this, we'd only have 5 fingers. So we might have a base 5 number system, especially if we had like 1 foot. Right? We'd have a base 5 number system. So that would be automatic. If I saw this, I would know it means the idea of 48. Is it really weird to look at? When you look at this, you think 143, but it really means 48 because the places don't mean what we think they mean because it's not a base 10. So real quick, stay with me. What does this number mean? If I don't write a base, it's our base. What does that number mean?
4,000.
Yeah, because 4 is in the thousand spot, right? 9 is in the hundreds. 7 is in the tens. 3 is in the ones. So I got 4 of these, plus 9 of these, plus 7 of these, plus 3 of those, is of course that. Yes? Because I'm converting within my own base. So I don't need to do that shit because it's already base 10. But I want to show you that is how every base works. You got to build it. So if I want to go from somebody else's base to my base, I write what each place is and I work out what the number is for us. Maybe. So let me try to give you. Crap. I gotta hire somebody, cameraman, camera person.
Or an aid.
An aid. Somebody. Okay. So here, figure out what this is from base 7 to base 10. Oh, let me put a little. So a little 7, right? It's not. Of course, you can use your calculator. If it's base 7, what are the places?
That's 1, 7, 49.
843.
There's
Skip
a lot
one.
more.
Yeah.
Oh.
Do I have another place? Oh, be careful. I didn't. It's 5, 3, 4, base 7, right? There's not 4 digits. There's 3. Are you with me? I don't know what happened. 5, 3, 4, base 7.
Oh, I was putting it into base.
Did you make it 5,347?
Mm-mm.
So if it's 5, 3, 4, it's definitely the ones place first, right? times 7 times 7. I don't need another one.
I was doing it like the back we would do for babies.
But we are doing like we did for baby. What was baby? Nobody puts baby in the corner. 1 times 60 is 60, times 60 is 36. See? 1 times 7 is 7, times 7 is 49,
Yeah, I think
times 7 if I needed it, but I don't.
Oh.
Okay.
I think what we did was, because it was 343, it could go into 534 once.
Yes,
Is that what you did?
that's what happened.
Oh!
I did the same
Okay,
exact
I
thing.
love that
That's
happened. I love that
exactly
that
what
happened.
Did you get 13?
Remind yourself when it's from a different thing to us, easy. There's no division, there's no subtraction, it's just multiplication and addition, and that's always easier, yes? Multiplying and adding is always easier than dividing and subtracting.
Okay.
So it's in, see, I really want to, I'm really happy that happened now, instead of like on a test or something. So you gotta you say to yourself, this is base 7. So this is 1's place, 7's place, 49's place. Why didn't I do it like this? So what you did was this, and you
Yeah.
went this high,
Yeah.
but that is if 534 was in base 10 and I'm trying to get it into base 7.
Oh.
It's already in base 7, so I already know what all these 7 things are. Because it's there already. Good. So now I just got to do 5 49s plus 3 7s plus 4 1s. Whatever the shit down is. What is it?
270.
270.
270? Neat.
That's it.
That's it.
Oh,
Okay, good, I was doing it right.
I'm so,
You.
I was so big.
Oh, why? Because I'm feeling I have to.
Don't worry, yeah, we're going to do it backwards. Not there yet. You mean like the way she was trying to do, right?
The only way apparently I know it.
Well, that is base 7 to base 10. You're talking about base 10 to base 7? Yeah, we're going to do it in a minute. Hold on. Hold on. Can somebody tell me, so 2 things I want to do before we do the backwards stuff. What is wrong with this number? Is there anything wrong with that number?
You can't have a 7 in base.
Can't have a 7. That would not make any sense, right? In base 6, what's base 6?
1, 6, 12,
36.
Sorry, 36.
Multiplication, I like it. How would I write 7? Would I need 1, 6, and 1, 1 to make 7? That would be 7.
So you're gonna have to
The
add-
numeral 7 would not exist if we had a base 6. In fact, does 6 exist in a base 6? No. I like it.
In base 10, does that mean 10 doesn't necessarily exist?
10 does not exist as a single digit. Let me be careful.
Okay.
So 7 exists, just not as a single digit. I appreciate that. Thank you. It definitely exists. It just looks like this, yes? It would look like our 11.
Mm-hmm.
But if I met an alien who had a base 6 system, this would mean 7 to them. Yes? Or whatever symbol they use for 1. Okay, so that's one thing. I like to ask that kind of question. How about this? What's weird about this idea? That's base 12, right? This is not weird. This is easy. This is easy. Let me be careful. There's something weird about base 12. What is this largest single digit in base 12? 11. Do we have a single digit that represents 10 or 11? No. All right, so let's worry about that in a minute when we start doing backwards shit, right? This is easy. I don't care what the hell it is. Going from somebody else to ours is easy, right? If you know the process, of course. So here I got what's in what? So I'm in base 12, so what is this?
1, 12, 144.
Good. So I got 3 of those, 1 of those, 2 of those. So what's beautiful is if it's in the base, I know these. They're filled in. If it's in base 10, I don't know those. That's when it sucks. That's when I got to figure out how far do I have to go. So now this is easy, right? Just do this old calculator. 3 of these, 1 of these, 2 of those, whatever the hell that is. 432, 444, is it 446? 446, right?
Yeah,
I got it.
446.
That's what I got. Okay. All right, I like it. Now, let's do some of this backwards. Let's start with base 12, just because it's the last thing we did. So what the hell? We got a major problem with base 12. Let me ask real quick. Anybody ever used base 16 before? Anybody ever look at HTML code? Anybody know what that means, HTML code? It's the language of websites and stuff.
Yeah.
Of course, they also use Perl and Java and all this kind of stuff. Numbers, I'm sorry. All right, you'll see why I'm reacting. Colors in HTML are represented by base 16. Because if you put all of them together, it actually represents the total number of colors that the computer can represent. So somehow it goes up to 15, right? So we're going to kind of lay the groundwork for that with base 12. So the way base 12 works, holy shit, Jeff, base 12, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, Jeff,
Is that an A?
that is an A.
An A? Is
That's
it
an
a
A.
B?
It's an A and a B. Isn't that the simplest solution to, we need a symbol that represents 10 in one digit. We can only write 10 in 2 digits, can't we?
So we go to letters?
So we go to
We
letters.
go
Why
to
not?
English?
If you ever look at, maybe I'll try to do this next time. If you ever look at the source code for a web page, you will see shit like this. Yeah.
It just looks like a hex code for colors.
Hex code for colors. That's
Oh,
exactly
okay.
it. So base 16. Sorry, I'm gonna get really excited right now. Base 16 is called hexadecimal.
Oh, jeez.
Hex code is hexadecimal, meaning base 16. Colors are represented in base 16, which is hexadecimal.
Oh,
Hex
that's
code
cool.
is what HTML uses for colors.
The
Kick
more
ass.
you know.
Huh?
The more you know. Yeah.
All right. So, for example, if I had this, what do you got, Jeff? 2, 3, A in base 12. And I want you to stop and think. If our number system was base 8, wouldn't you all right now be freaking out just as much about me talking about base 10?
What?
Wouldn't, if our system was base 8, what would be our largest single digit?
7.
So then I say, what about base 10? We need a single digit for 8. We would be freaking out just as much as we are now. So why is it freaky? Because it's different from what we've used our entire life. Would we have used this symbol? Probably not, right? But it's just a stand-in for whatever symbol we would have used. Right? Where did the symbol 9 come from? Somebody had to invent that. So somebody would have invented this symbol if we had 12 fingers. We would have a base 12 number system. So what does this mean? What place is the A in?
12.
The ones.
One's place.
Wait.
It always starts at 1.
One.
Oh, I thought you said the 3.
Oh, no, the A. And then the 3 is in the 12s. And the 2 is
144.
in the 144s, right?
Mm-hmm.
So it'll be 2 144s plus 3 12s plus 10 ones.
Jesus, that's a lot to take in, but it makes the problem a little easier since you were.
Well, it makes it possible. Before I introduced that, it was impossible to represent the number 10 in a single place. But we really just had to pick a letter, and unfortunately, we can't pick because this is a standard way to do it. Right? It would have been more fun to say, what symbol do we want to use?
T.
No, yeah, T for 10 makes sense. And 11 would be E. Why not? Yes? Why not? But we can't do that shit because it's already been picked.
The 11 should be H because of the 2 ones.
I like it. Why not? It's too bad that we can't do it. Right, and then you just multiply and add. Is everybody with me? Is that all right? So, shit. I'm pointing in the wrong direction. What if I had to do, what do you got, Jeff? I don't know, man. I don't know. Let's do, 191, base 10, I want to take that to base 12. So what would we do?
Like you would do for babies or.
Yep, same thing.
Lay it out.
So now they are blank. The spots in the base 12 place value system is blank. Because I don't know what it is in base 12. I know what it is. So if I write 1, 12, 144, the next one is who? Out of curiosity?
17, 28.
17,
28.
28, that's too much, right?
Mm-hmm.
Trust me, you almost always want to go too much, just to make sure you went far enough. I cannot fill those in yet, right? That's when I know it's hard. I'm not in base 12, so I don't know what those are. Yes?
You're not gonna make us go far enough in the test, right?
What?
I said,
Oh.
like far enough, like, for example, if you were to give us a number like higher than that, are you gonna give us a higher number?
I totally could. I could have made this 1912, right? And then you would have needed this place, correct?
Mm-hmm.
Then you would have went, see, on this problem, do you really have to go here?
No.
Isn't it pretty obvious? So I'm not going
No,
to take
kinda
points
no.
off if you don't do this. Is that what you're really asking?
Sort of,
Okay,
yeah.
I'm not going to take points if you don't do this, but you should get in the habit of doing this because it is very easy to not go far enough, and then that just throws everything off. Okay,
I'll have it with you.
this is not that bad, is it? How many of these do I need?
One.
One. What's left?
47.
47. How many of these do I need?
3.
3. What's left?
11.
11. So what is the real answer? 1,
4.
3.
Okay.
A is 10.
I did this
B.
Oh, okay.
1, 3, B. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B. Right? A is 10. B is 11. Yes.
Okay, so I think I'm just trying to ruin my own life. But, so what happens if we run out of letters? Does that make sense?
I see what you mean.
I think I'm just being
For
paranoid.
example, did we already see one that was higher than base 26? Aren't you worried about that? Isn't
Yeah.
base, well, it'd be base 26 plus 10, so 36, right? So we'd run out of the letters that we need for single digits. We've already done that. Babylonian does that, and they had an entirely different system. What would we use? Maybe we start using Greek letters.
Oh no.
Yay! Some pies and some rhos and some lambdas and some, maybe not delta. Had enough of delta.
Isn't delta an actual like math symbol?
Say again?
Isn't delta a math
It
symbol?
is. Unfortunately, it's also a variant of the coronavirus. So that's why I don't
Is
want
it
to
the
do it.
triangle?
Huh?
The delta.
Yeah, the little triangle. I love it. That means change in,
Yeah.
in algebra and
Like
stuff.
the y equals mx squared.
I like it.
Oh.
All right. So, let me see. I don't know the book. So what do you think, real quick, what do you think base 16 would involve? So get the moaning out of the way.
1,
Like
16 to 56.
So you need a symbol for 10, you need a symbol for 11.
Oh,
So what's 12?
C,
D,
What's 13?
D, E,
F.
Do we need more? Do I need 16?
A G.
No.
Yeah, no.
Why do I not see 16? Because 16 would be 1, 0.
yeah.
Because it's base 16.
The highest single
Digit.
What's our base? 10. How do we represent 10? 1, 0. Base 16. How do I represent 16? 1, 0. Why? Because 1, 0. This is 1s. This is 16s. That's 16.
Oh.
I got it. It's in here.
All right. So next time, we'll do a little manipulative stuff. We'll finish up a few things in 2, 3, and then the rest of the time will be devoted to review for the test. I'll have a practice test with me that you guys can work on.
Cool.
Thank you.
You're welcome.